Proxmox provides a really useful graphical user interface for Proxmox VE that makes managing a cluster and virtual machines relatively straightforward. But manually creating virtual machines takes time and usually just repeating the same process over and over again. No doubt those virtual machines are important, so you'll buy more storage so you can make backup copies of them locally, and then pay some more money so that you can have offline copies as well. But if you consider the time it would take to recover your backup copies from an offline storage, and then how long it would take to restore your virtual machines, automation with a tool like Ansible makes more sense. Because if you can create and manage your virtual machines from code, then aside from any data that's generated, that code is all you need a backup of to be able to rebuild your virtual machines. But how can you configure Ansible to create a virtual machine on Proxmox VE? Well, if that's something that you're interested in finding out, then stick around and watch this video, as that's what we'll be going over. Now, because this video is specifically about creating virtual machines using Ansible, I'm going to have to make some assumptions. Firstly, that you already have Ansible installed, or at least you know how to install it. If not, then I do have a video that provides a crash course on Ansible, including how to install it. Secondly, I'm going to assume you know how to set up Proxmox VE servers to allow Ansible to manage them. If not, then I do have a video that covers that. And lastly, that you know how to use Ansible Vault to encrypt sensitive information like user credentials. If you don't, well, I also have a video which shows you how you can create, manage, and use Ansible Vault files. Now, to get started, what we're going to do is to create a playbook which, when Ansible runs it, will create all of the virtual machines that we tell it about. So for this video, what I'm going to do is to create a new folder first called VMs. Then I'll swap to that folder. And then I'm going to use nano to create my playbook, which I'm calling build_vms.yml. In there, I'm going to copy and paste in details of the playbook itself. And right at the top here, you can see the first thing we're doing is to target the local host. In other words, this is the actual Ansible computer itself. The reason being is I'm going to get it to create some variable files on the computer. So these are files that contain information about Cloud-Init images, as well as the actual virtual machines themselves. And I'll go into this a lot more detail later on. But essentially, I want to maintain this information as separate files. I don't want one big long file for my virtual machines, for instance. I want individual files. It's a lot easier to maintain. So what we're doing here is, at least at the time of recording, this seems to be the preferred way to loop a role, because that's what we're doing, is to call a role, which is going to go to a folder, pull all of the files in that folder together and create one file from it. But I want that looped. So I need to do it once for the images and once for the virtual machines. And that leaves me with what is essentially dictionary files for these two. Once it's done that, we then turn to the actual Proxmox VE servers. So first I'm targeting all of the servers. Now I've got a group called PVE nodes in my inventory file, and under that is the actual list of the actual servers in the cluster. And what that then does is to call two rules. One is to download the Cloud-Init images themselves, and then it creates these user files. So these are individual files for each individual virtual machine they're going to get created to finish off that Cloud-Init process. Because when the virtual machine first boots, it goes through the process of starting up, but then it needs answers to finish the process off, and that's where these user files come in. We'll go into this in more detail later, but the last thing to do is to then actually create the virtual machines themselves. Now you'll notice a slight difference here, where here we're targeting all of the actual servers. Here I'm only targeting one. I'm specifically telling it to connect to the first server in the actual group. The reason being is things get really, really complicated. It's just too difficult, as far as I can see, to handle. If I was to get it to call all of the actual servers, it's better to target one server to do this. Still end up with virtual machines on individual actual nodes, but this to me is the simpler way of doing it. So the assumption is that everything's fine as far as your cluster is concerned. All of your servers are up and running, and they can all support the actual virtual machines that you need to install. Because, as I say, if I were to target all three at the same time, it just starts running into problems. It's just not practical. There's bound to be ways around it. But to me, I want to keep things as simple as possible. So for that reason, I'm only going to get to target one specific node, and then it'll take care of the rest. But in any case, that completes our actual playbook. Now the next thing we'll do is to start creating the variable files that I was referring to earlier. And we'll begin with the ones for Cloud-Init. So I need to create a new folder and a subfolder within there. So that's why I'm using make-dir with the -p parameter. I'm then going to get it to create a new folder called variable_files, and within there a folder called images. Now, although what I'm going to be doing is to set up files that define images that I want downloaded, I need these all assembled into an actual variable file or dictionary by Ansible so that I can use them. That means I need a header file to begin with. And, well, I thought I'd call that a header.yml. And to be honest, you can call that whatever you like, but the reason I've called it that is just so that alphabetically it is the first file in the actual list. Because when I hit return, what goes in here is the name of the actual variable itself. So I'm going to save that. Then I can actually start creating the actual files themselves that define the actual Cloud-Init images. So first one I'm going to do is for Debian 11. And the details that go into these files are basically the same. They've just got slightly different information in them. So this one's been given a name of Debian 11-image. I've got another variable in there called Cloud-Init file, which actually tells you the name of the actual file. Then an image URL, which points you to the actual image that you can actually download directly from Debian. Then an image checksum, which you can get off their website as well. And then I've got a state of present. Now, one thing I'll point out is the spacing. This has to have these two spaces at the beginning. The reason being is that these files are all going to get assembled together, and they have to be in a proper format for this to be able to work. But one thing I will point out is that the checksum that I've got here is going to change over time, because what we're downloading is the latest version. And what you'll find is that if they upload a newer version, there'll be a different checksum and the actual download would break. So you've got to keep your eye on this. Every time you want to actually download an image, make sure that the actual checksum is correct before you do that. Even if it's going to try and override it, might have a problem if the checksum has changed. But I'll leave a link in my blog and in the description to tell you where you can actually find details about all this. Now, I do have at the end an option for the state, and I've set this to present because the idea is I want the actual playbook to actually install this. But the idea is at some point in time, these images, they're just no longer used, in which case what I can do is have another playbook to tidy things up. And what I can do is just set the state to absent, for instance, and then I could get Ansible to actually delete the image once it's no longer actually needed on the computer. But I'll save that file there. And I'm going to do the same for Debian 12. Now, technically I don't need the one for Debian 11. I just want to demonstrate how you can get this to maintain multiple images, basically. So essentially it's the same, except this time we're referencing Debian 12 here. So I'll save that. But the key thing to point out is if we have a look in that folder, you'll notice how the header file comes first alphabetically. It has to, because like I was saying, that this one defines the name of the actual variable, and then what follows is the contents of those files, at least once the actual final dictionary file gets created. So that has to be the first file alphabetically. But in any case, we've now actually defined the details about our Cloud-Init images. Now, the next thing to do is to create the virtual machine files. But before I can do that, I need to create a folder to store them in. So I'm going to call this VMs, and it's going to get stored in our variable_files folder. I'm then going to create a header file, but this time I'm going to call it 0.yml. Then I need to store the name of the actual variable that we'll be using, and then we'll save that. And then we're going to create our first virtual machine file. Now, this is going to be called 100.yml because that's going to be the actual virtual machine ID 100. That's the reason why I've got a header file called 0.yml, because this has to come first alphabetically. We'll then copy and paste in the details that define this virtual machine. So we've got a name, a virtual machine ID of 100, which matches the actual name of the file there. What node to install it on, what image to use, how many cores to give it, how much memory to give it. Now, this line here defines the VLAN tag to use. Now, VLAN 1 isn't a good idea, but because I'm using nested virtualization, it just makes things a bit easier for me to test out VLAN tagging. The key thing is, if you're not going to be using VLAN tagging, you don't want to be using this. It's going to cause problems for you, but you can actually ignore that within the role if you want to, or just basically remove it as the actual line within the actual file itself. It's entirely up to you, as you'll see later on. But anyway, we need to tell it about the IP addressing as well. So in this case, I'm going to give this one a static IP. So I've got its mode set to static. I've got its IP address here, as well as the actual gateway. Now, the rest of the information is going to be hard-coded into the role, but once we get to that point, as I'll show you, you can actually be more flexible if you want, or more strict. The idea for me is that most of this information that I've got here is going to vary depending on the actual virtual machine. These are the sort of settings I want to change. The rest are going to be hard-coded within the role, but you can change this to suit yourself. As long as you reference a variable within the role, you can define it here. On the other hand, if it's set to a static within the role, well, it will just get ignored within this file. So there's been a lot of, well, basically there's a lot of flexibility here. It's entirely up to you how you want to do this. One last thing I'll point out is that the state setting that I've got is new. The reason being is that there's some post cleanup work to do. I don't want to touch virtual machines that are already up and running, basically because part of that cleanup job is going to actually be shutting virtual machines down, and I don't want to shut a virtual machine down if it's already up and running. So for that reason, I set the state to new so that I can identify virtual machines that I can actually shut down without touching the existing ones. Afterwards, it'll get set to present, but just for now, it's got to begin with that setting of new, otherwise it'll just get ignored within the playbook. So we'll save that file. Then I'm going to create another virtual machine. So this is going to be 101, because that's what its virtual machine ID is going to be. So basically the information is the same, except just different values. So this one's got a virtual machine ID of 101. We're going to be using Debian 12 in this case. I'm going to put it on a different node, more cores, more memory. And this one's going to be using DHCP. So there's no point referencing any of the other settings about the IP address or the gateway, because that all gets provided as part of DHCP anyway. So we'll save that file. And then if we actually have a look in that folder, you'll see the header comes first, and then they're all going to be in order of the virtual machine ID. So from my perspective, the way I'll be maintaining these is through a spreadsheet with my virtual machine IDs in one column, name of the computer, details about the computer in the other, because over time these virtual machines will get repurposed. And the way I'm thinking about this is that I can basically just set up new files for new virtual machines that need creating, and then Ansible will take care of basically creating them all. So all I've got to do is just maintain these files. But anyway, we've now got all of our virtual machine files created. Now, because it's better to use variables than hard-code values in your Ansible files, we're going to be setting up some group variables. Now, I could use variables within the actual roles themselves, but doing it this way allows me to centralize them. And it also allows me to actually share common variables across roles as well. First thing to do is to create some folders. So I need to create a folder called group_vars, because that's where Ansible is going to be looking. And then within there, I'm going to create a folder called all. So these are going to be variables for all devices. And then another one called PVE nodes, which is going to be for the variables for our actual group PVE nodes. I'm then going to create a file, and I'm just going to call this one vars, but you can call it whatever you like. And that's going in the all folder. And these are the variables we're going to put in there. So I'm defining where to find the actual public key for Ansible, what this project path is, The image path is where to store the actual Cloud-Init images. Then we've got some settings for the virtual machines, including the domain name, the time zone, and the locale. There are times when I need to reference that group for my actual Proxmox VE nodes. So I've got a variable here of group_name for that. And then because I'm looping this role to actually create these dictionary files that I've called variable files, I'm using a variable here that allows me to do this looping. So we'll save that file. Then I'll create another one, which is for the actual PVE nodes. So again, you can call that what you like. I'm just going to call it vars, but this is going in the PVE nodes folder. And just copy and paste in the details for that. Now, when you connect to Proxmox through the API, you've got to tell it what actual host to connect to, and that's known as the API_host value. Now, because I'm actually having Ansible here connecting through an SSH session, I'm just trying to be a bit flexible and take advantage of something we already know about what we're already connected to. So I'm just using this variable of inventory_hostname. So we log in through SSH and then we log into the same computer using the API, but you can change that if you like to something else. Now, the virtual machines themselves, the hard drives, need to be created and stored somewhere. So I've got a drive_storage variable, and it's telling it to basically put these hard drives in an actual storage that I've called VMs, but you'd have to reference that as, to what your storage is called. And then I need to actually define the drive format. QCOW2 is the preferred one, but it really depends on the actual storage you've got. You might have to actually set that to raw, for instance. And these are going to be global variables rather than virtual machine specific, because for me, all of these virtual machines are going to end up in the same storage. If you're going to put yours in different ones, then you're going to have to update the actual virtual machine files to be able to do that sort of thing. We've then got some information about snippets, and that's to do with the actual Cloud-Init user files we're creating. Now, because these are just small files and they're only temporary, what I'm going to do is I'm actually going to create these in the local storage, and they're also going to be in that specific folder. We'll cover that in a bit more detail later on, but I need to be able to reference that for actually creating those user files. And then when it comes to the images, well, the API needs information. It can't reference an absolute path when you're using the API. So I've got to tell it where the actual storage itself is. So if you were to log in as root, you could actually reference an absolute path, but when you're using the API, you've got to reference it by a storage. So that's why I've got that there. And then finally, all of my virtual machines, they're just going to end up on the same Linux bridge anyway. So that's why I've got that defined as a global variable. Again, if you want to put yours on different bridges, you're going to have to alter those actual settings within the actual role that we set up, and also within the actual virtual machine files. But I'll save that file, and that gets us our global variables. Now, some variables that we're going to be using are better encrypted, so we're going to take advantage of Ansible Vault. So the first thing we're going to do is to create a Vault file, the variables that could apply to any of the computers in the actual inventory file. So for that reason, it's getting put into the all folder. Now, I'm going to call this Vault, but you can call it something else if you like. I'll hit return. Now, it didn't prompt me for a password, even though this is a new file, and that's because I've got ansible.cfg actually configured to point to a password key file, so it already knows what the actual password is going to be. Then I'm just going to copy and paste in some details. So one's going to be the name of the actual Ansible user, and the other is the IP address of the computer that Ansible's connecting from. So I'll save those. Then I'm going to set up another Vault, which applies to the PVE nodes. That goes into the PVE nodes folder. And I'll just copy and paste in those details. So these are basically the login credentials to get access through the API. So the API user, the token ID, and the token secret. So with those two files created, we've now got actual Ansible Vault files. Well, now that we've defined our variables, the next thing to do is to start working on the roles. And we'll start with creating a role which assembles some files together out of a folder and creates one file in a destination. The reason I need that is because I need dictionary files so that I can get Ansible to create multiple virtual machines, as well as to download multiple actual Cloud-Init images for me. So what I want to do is to create several folders here because it's a role. So I need to have a folder called roles, and then we have a subfolder after that, which is the name of the role. And then within there's going to be a folder called tasks. Now, Ansible is going to be looking for a file in there called main.yml. Then I'm just going to copy and paste in the details. Now, there's actually more commentary in here than there is actual instruction, basically. But what we're doing is to use the assemble module to basically look in a folder and then create a file in a destination. Now, because I've got Ansible going off talking to Proxmox, I've got to point it back to the local host just to be on the safe side here, because I'm going to use this in other projects as well as not just this specific project, but I need to make sure that these variables get created on the actual computer itself that Ansible is running on. But what we're doing is to take a project path, and then within there we're going to be looking for a folder called variable_files. That's where we're basically keeping our actual Cloud-Init images and our virtual machines, but they each go in separate folders. That's why I have this variable_name. So this is what the actual Playbook's passing across as a variable to this actual role when it's actually running. And then essentially what we're then doing is creating this new file, but that goes in the project path and then into group_vars. And then where that then goes depends on the name of the actual group, plus again the variable name again that we're going to be calling it. So what we're then going to do is save that file, and that creates our actual assembly rule that we're going to be using to create these variable files. Now the next rule to set up is the one that downloads our Cloud-Init images. But first thing I need to do is to create some folders and subfolders for it. So our roles go into a roles folder, and the subfolder is named after the role. And then within there you need a folder called tasks. Ansible is then going to be looking for a file called main.yml. So I'll now copy and paste in the details for this role. And what we're going to do is to make sure that we've actually got a folder to download to. So for that I'm using the actual file module here to make sure that we've got a directory created. And then what we do is to actually download the actual Cloud-Init image, and we're using get_URL to do that. So we point it to the URL, tell it where to download to. We're also going to then do a checksum check to make sure that the actual file we're downloading is legitimate, hasn't been changed in transit or hasn't been altered while it's on the website and doesn't match up with the file that was created originally. Because we're going to be downloading multiple images, I've also got a loop, and that's referencing a dictionary that the previous role will have actually created for us. In other words, it'll have taken those image files that we created and merge them all together with that header file to create one dictionary file that we can use here, and we just need to reference it by the variable name. Now, because I've got a state within those files, we're actually taking advantage of that here to say that if the state is present, then yes, we'll download the file, otherwise we'll just ignore it. But then later what we've got is another option here where we're using the file module to actually delete any of these Cloud-Init images if its state is set to absent. So we're now going to save that file, and now that gives us an actual rule to download Cloud-Init images. Now we're using Cloud-Init to create our virtual machines, and part of that process involves handing over an answer file to actually finish the installation process. But when it comes to Proxmox VE here, it's going to be looking for these files in a storage location that supports snippets. So to set that up within Proxmox VE, what you can do is navigate to Data Center, then go to Storage. Then what you would do is to actually select your storage. Now the way I've got this set up is that these are going to get stored in local. So I need to select local and then click on Edit. Click on this drop-down menu called Content and select Snippets. Just click somewhere else and then click OK. So you can see now it's actually saying that it supports snippets, and even tells you what the actual path is, /var/lib/vz. So what that does is if an actual folder doesn't already exist called snippets, it actually creates one there for you. So that's all you have to do on Proxmox VE to actually set up support for snippets. Now, because we're taking advantage of Cloud-Init, we need to create user files for each of the virtual machines we want created. So to do that, we're actually going to be using a rule. First thing I'm going to do is to actually create some folders and subfolders here. So rules are expected in the rules folder. You then have a subfolder in there named after the rule, and then within there another folder called tasks. Then Ansible is going to be looking for a file in there called main.yml. And then what I'm going to do is copy and paste in the actual details for this rule. And the way I'm doing this is to take advantage of templates. So there's going to be an existing file with various information in it. We're then going to make some modifications to that on the fly, but then copy it over to this snippets path that we've defined. But we're actually going to name the file based on the actual virtual machine ID, then -user.yml. So each of these files will be unique. Then we're going to set up the permissions, and then we're going to loop this process for all of the actual virtual machines we want to find. And we're only going to do this when it's actually got a state of new. The reason being is these files are going to get deleted, so this is pretty much a one-off process. I don't want these files lingering around with certain information that I don't want easily identified. So it's part of the cleanup process will be actually to delete these files. So I don't want these files creating every time the playbook runs, only when a new virtual machine is being created. And then finally what I've got is a setting here to actually disable logging to the screen, because there's certain information I don't want actually showing up on the screen while this is running. So we'll then save that file. Then I need to set up a folder to store the template in. So that's a folder called templates. Then we'll create the actual template itself, which is using Ginger2. So I'll just call this user_template.j2. And then I'll copy and paste in the details, which basically goes above and beyond, shall we say. So it has to start with #cloud.config. You can actually get a dump of this if you want. If you go into the GUI, when you've set this up to create a virtual machine, for instance, with a Cloud-Init drive, you can actually get it to dump the actual settings for the Cloud-Init drive, and it gives you information similar to this. But that's how I got most of this, except that I want to go beyond just that. I want a virtual machine that will be up and running and enough to support Ansible, basically. So there's other information that I've added to it. The only trouble is with Debian, it doesn't quite go as far as, say, Ubuntu. So there's some things you can do and some things you can't. But the way I've set this up is just to get me over the line. So as I say, I can hand this over to Ansible, but at least it's some way secure in some respects. So what we do is we set up a host name. I've also got a setting to actually change the host's file, because basically we're changing the actual name of the computer. We're setting up the FQDN, we're telling it what the user account's going to be. In this case, it's going to be our Ansible user. We're also pointing it to our actual Ansible's public key file is, so we can upload that. Now, we're not going to provide an actual password for this actual user account. Part of the reason being is part of the automation for Ansible. You don't want interaction if you're going to be scheduling a task. But all the same, I'm going to make sure that any passwords don't expire. Now, this particular line here, users and then -default, that still shows up. Even if you go into the GUI and set this up, and you don't want the default Debian user account, this still shows up in the dump. So I'm still going to keep that there all the same. You don't actually end up with the Debian user, fortunately. We'll still just end up with our Ansible user, but it's just because of the way that was presenting, at least that worked. I'm just going to stick with how they've done it. Then we've got some settings just to do any last minute update or upgrade if possible. While we're here, I'm going to set up a time zone for the virtual machine. But one of the things I quite like with this is you can actually install software and you can actually run commands once the actual virtual machine's up and running. So what I'm going to do here is to install the actual QEMU guest agent as well as the uncomplicated firewall. Then what we're going to do is to run some commands to enable the actual guest agent, make sure that it always gets started. And then I'm going to set up some firewall rules to basically restrict access to only my Ansible computer. So it's the only thing that will be able to get access to a virtual machine, only using SSH. And then we enable the firewall once we've defined the rule. And then finally, I want to make sure that we've got some locale settings. So I'm just setting up the actual locale. With these Cloud-Init images, you just get the bare bones. So I'm getting the actual one that I want generated, and then I'm setting that to the one I need. And then finally, I've got another line which it actually changes the name of the user account. So even though I've actually got it to create a user account, the problem is the name of the actual user ends up as Debian. So I'm deliberately changing it here as a last line over to Ansible instead. But it's very useful, this, I must admit. I mean, as I say, it's not as flexible as, say, what you can do with Ubuntu, but this is enough for me to be able to get a unique virtual machine up and running, get the actual guest agent up and running as well, and get the firewall in place to actually restrict access to it. So I do really like that, especially the fact that we also set things like time zones, but other things like that, to be honest, you could fix later on, because the idea would be once these virtual machines are created, you'll be handing them over to Ansible anyway to maintain, but quite useful that I do quite like it. So we'll save that template, and then that gives us a role to actually create our user files. Now the last role that we need to create is the one that creates the actual virtual machines themselves. But before I can do that, I need to create some folders and subfolders. So Ansible is looking for roles within a folder called roles. We're going to call this one create_VMs. Then within there, we need a folder called tasks. Then Ansible is going to be looking for a file called main.yml. So I'm now just going to copy and paste in all of the details I need to actually create this virtual machine, or in this case, all of the virtual machines I want to create, because it's going to do all of them in one pass effectively. So the first thing we do is to actually create the virtual machine itself using the Proxmox_KVM module. And these are all of the settings that are going to go into actually making a virtual machine. So some of the information is coming from bulk files, for example. Some is coming from our machine actual files that we've set up. And some of these settings are actually hard-coded. So it's entirely up to you how you want to do this. The way I've got it running is that some of these settings are going to be permanent, so I'll just leave them within the actual setting of the role itself. They're not going to change. For example, I don't want any of these virtual machines to boot as soon as it's actually created. For example, I always want to be using host as the CPU. So it's entirely up to you what you want to do, but I quite like it this way. Now, one thing I will point out though is that I've got a setting here within the network settings to actually define what the VLAN tag is. Now, if you're not using VLANs, you'll actually want to remove that actual setting there within this line. Otherwise, you'll end up with problems where traffic will come in with tags and it's not expecting tags, or vice versa, and you'll just run into problems. So if you're not going to be using any VLAN tagging within Proxmox VE, then don't include that block. So that's from the comma right up to that last curly bracket there. Now, what we're using here is Cloud-Init to actually create these virtual machines. So I'm actually getting it to import the Cloud-Init drive. The only thing is, when we're going in through the API, we can't use absolute paths. We've got to point it to the actual storage location. So for that reason, what I've got here is I'm pointing it to the actual storage location, which for me, it's going to be the local storage, and then the actual folder, which is why I've created this folder 0 within the actual local storage, and then we'll point it to the actual file to import. I can't do that as an absolute path. It's got to be defined as a storage because we're using this Proxmox KVM module. And because we're using Cloud-Init, I've also got to get it to create this IDE drive for Cloud-Init to use. Now, lower down, what goes with that is this setting here to actually point it to the actual user file that we've created. And each individual virtual machine that we create will have its own file. So this file essentially just gets compiled, if you will, into an actual ISO file that goes with this actual IDE drive. Now, lower down, I've got a timeout of 700 seconds. You might have to alter that. It really depends on how long it takes to create a virtual machine. Sometimes I found it might be 10 minutes, 11 minutes. So That's why I've got it at a setting of this high, because if it takes too long, Ansible will just fall over. So you might have to increase that size, otherwise that might be fine. And then because I'm going to get it to create a lot of actual virtual machines here, I've got a loop option which points it to this dictionary file that basically contains all the information for all of the virtual machines. And then I've got a condition to say, well, I actually only do this if the state is actually set to new, because there's no point if the virtual machine already exists. And then finally, I'm disabling logging, especially because we've got sensitive information that would otherwise pop up on the screen, for instance. It's going to basically loop through this whole task to create all of the virtual machines, so it is going to take some time. But once that's done, I need to update the network settings. Reason being is I'm setting it by default to DHCP to get the IP addressing, because some computers will use DHCP, some are going to use static IP addressing. So the way I've done it is just create all of these virtual machines to use DHCP, and where I've actually set up the actual file with some details about static IP addressing for those computers, then go back and alter those IP settings. That's what it's doing here. And then because the actual drive is only 2 gig, I'm getting to actually resize the actual drive for us. 2 gig might be fine, on cloud server solutions, for example, but I'm just going to go with that default size of 32 gig that you normally get for Linux computers through Proxmox VE, but you can alter that if you like. And what it's going to do is literally loop through all of these actual virtual machines it creates to increase the actual size to 32 gig. One thing I'll point out though is that if you go through the GUI to resize a disk, it actually asks for the amount of disk space to increase it by, whereas with this Proxmox_disk module, it wants to know the actual absolute value. So if you go through the GUI, well, if you want to go from 2 gig to 32 gig, you would put in 30 gig, whereas when you're using this module, I've got to tell it 32 gig. So that's just something to bear in mind. I mean, they've all got timeouts within these. I mean, 60 seconds seemed okay for me, but again, you might have to adjust these. It depends on what you experience. Then finally, what we've got to do is to actually start these virtual machines up. That's to actually get the Cloud-Init image completed, because what it's going to do, it's going to boot up the virtual machine for the first time. It's then going to use those answer files to actually finalize the installation, and then the actual virtual machine is ready to use. So I've got to go through that process of then actually getting these virtual machines started. So that's part of the reason why I've got it set to no, to don't boot straight away as soon as the virtual machine's created, because there's other things I needed to get finished first. But I do have to actually get that virtual machine started at some point, just to get the Cloud-Init image finalized basically, and it leaves us with an operating system that should work. So I'm going to save that file. We're in the main folder. So $64 million question is this going to work? So the playbook's called build_vns.yml. I've got my ansible.cfg file set up, so I don't have to provide any other information. It knows where my inventory file is, it knows where the vault key is, and so on. So I'm just going to hit return, and yeah, just wait. Well, as you can see, the actual playbook has finished. Although the eagle-eyed amongst you, if you're familiar with Ansible, you'll notice that some of these are saying okay. Now, wouldn't really expect that on a first pass, and that's because this is actually the second pass. Yeah, as luck would have it, I ran this on the first attempt, and sure enough, Debian's actually updated its images, in which case the checksums failed. And so for that reason, I had to actually go back to their website, get the latest checksums, and update my files about those, then run the playbook again, and oh, it's gone. This time it's managed to download the actual images, and off it went and finished everything else off. Now, you might think, well, that's just a bit of a hassle. In fact, it's too much hassle if you're going to have to do this every time an image gets updated. But It's just an extra security check, basically, just to make sure you're downloading a legitimate file. It hasn't been altered in transit, for example, or you haven't downloaded it from a malicious site, that sort of thing. But it's entirely up to you. It wasn't that much of a hassle for me, so I'm not really too bothered. I'd rather have that extra security check. But yeah, it's just one of those things, basically. It got so far, and then it was like, oh, we've just decided to change these checksums in the last 24 hours, because that's literally what happened. All the other sections I've done up to now were done yesterday. I've then just picked up from there to finish this last part of the playbook off, and as luck would have it, yeah, the images got updated. But yeah, still having. Anyway, if we go over to Proxmox VE, let's see, I've now got two virtual machines. So I've got virtual machine 100, VM test 1, is up and running on server 1, whereas the second virtual machine is up and running on server number 2, and that's the way I deliberately set it up. Now, the first thing to point out, which is good news, is the fact that if I have a look at the virtual machine, go to its summary page, it's coming back with IP addressing information. That tells me that the actual QEMU agent, the guest agent, is actually running. And that's extremely useful, because straight away it's giving me the actual IP addressing details. So I've got 192.168.102.40. Now that's the static one. If we go to server number 2 that I built, that's come back with 100. So that just happens to be the first IP address in my DHCP scope. So that is good news. It means I've now got two virtual machines built, and they look to be up and running. Now, although I've now got some virtual machines that are up and running, there is some post-cleanup work I want to do. I don't like to leave things lying around, information particularly, and there's no longer any need for this Cloud-Init drive. So what I'm going to do is to create another playbook just to tidy things up. And I'm just going to call this post_cleanup.yml. Then I'll copy and paste in the details for what this is actually going to do. So the first thing we're going to do is we're going to go through all of our actual Proxmox servers, and we're actually going to delete all of those Cloud-Init files that we created, all of the user files for each individual machine, but only if it's got a state of new. The reason being is that those files have got user information in them. I mean, granted, the only way you should be able to get access to that computer is through Ansible or through the actual root user account, but all the same, I just don't like leaving user files lying around like this, because they've got sensitive information in them, so I'd rather remove them after we've created these virtual machines. Then what we're going to do is to actually remove the actual Cloud-Init drive itself, because there's no longer any need for it. Once you've actually booted the computer up and that process is finished, well, that's it. I don't really see myself wanting to regenerate the image, for example. I'll just build a completely new virtual machine if I was going to repurpose the virtual machine ID, for instance. So for that reason, we're pointing Ansible just to the first Proxmox server in the list. Otherwise, we'll run into complications if we try to do this on every server. But what it needs to do first is to actually stop the virtual machines, because when you're changing hardware in Proxmox VE, some of these things actually require you to stop the virtual machine, then power it back up again. So I may as well just stop it in the first place. But again, I don't want to stop all computers that are running on a computer, especially existing ones. So we're going to make a check that the actual state is set to new before we actually stop any computers. Then we'll actually remove that IDE2 CD drive from the actual virtual machine. Now, one thing I found is it's best to actually pause a while, take a bit of a breather before we proceed on to the next stage, which is to actually start those virtual machines back up, because there might be a bit of latency in the feedback. And if Ansible here thinks that the actual virtual machine hasn't stopped, well, it can't start it. So in this case, I'm pausing for about 30 seconds before we then carry on. But you can alter that if you like. It really depends on your situation. But for me, 30 seconds seemed fine. But once we have waited, then we'll start the virtual machines up, and that should finalize removing this Cloud-Init drive. Now, the last thing I want to do is to basically do a bit of another cleanup, which is to actually change the state of those files that define our virtual machines from new to actually present, because, well, that's it, they're now ready, they're actually more or less in service. I mean, granted, it's just an operating system, but it's it's now finished. We're finished with those virtual machines. We don't need to do any more in terms of actually building the virtual hardware, if you will. So I'm actually going to get it to replace any setting of present within the file to new. And then because of that, I then need to get it to update my dictionary file that would normally get created. So rather than doing this every time a new project gets run, I'm going to get it done now, really, so that these virtual machines are all ready to go. And then they'll know that basically these machines are actually working machines that they can actually use. So I'm going to save this file. And then we're actually going to start this playbook. Hit return. Now that's going to take a bit of a while because it's, as I say, it's got to actually stop the virtual machines, and then we've got to pause. There you go, our actual playbook is now actually finished. So now I'm over to these virtual machines now. They're still running, they're in the process of booting up, so you can see the actual guest agent isn't showing anything. So I've got to wait for that to actually finish booting up. But if I go into the hardware, yeah, the IDE drive has now finished, and the actual user file should have gone as well. So I'll go into the shell. So it's cd/var/lib/vz. So we've got a folder in there called Snippets. So if I have a look in there, all of the user files that got created went into there. So they're actually now removed. But if I look in the images folder, in here, we've still got a folder called 0. And if we look in 0, my actual Cloud-Init images still exist there. So I'm quite happy for those to stay there. It was more the actual user files in the snippets folder I wanted to make sure were removed. So that's done my post cleanup work for me. And it looks like these virtual machines are now up and running. Yeah, back up and running now. Now, looking at Proxmox VE here, it does look as though our virtual machines are actually ready to go. And I can tell that because the actual guest agent's installed. Now, you don't get that as part of the normal Cloud-Init image, so that is a good positive sign. But all the same, I do want to do some last-minute testing just to be on the safe side. So this one here has a static IP address. This one here has a dynamic IP address. So this is now 102.102. So what we're going to do is to actually log into these and just see what we get. So I should be able to log in as the Ansible user. I do have to point it to my actual Ansible key. First time I've logged in, so I need to say yes to the fingerprint there. Then one of the things I got it to do was to install UFW. So we're going to have a look at the firewall status. So that's a good sign. The firewall is active and it's restricting access to SSH only access and only to our Ansible computer. So that's exactly what I wanted it to do. I did ask it to change the locale. So have a look at that. Well, that's good because that's the one I want, which is English, Great Britain. Then I'm just going to check to see if the time zone has been set as well. Yeah, that has. That's on Europe/London, so that's good to see. We'll jump out of that one and then we'll check the other computer. So we should get the same results for that one. So we'll check its firewall. Yep, firewall's active and it's blocking access, allowing only SSH access for our Ansible computer. Locale setting, English, Great Britain. That is something I find a bit odd, I must admit. Sometimes I get this where it says it's unset, and sometimes I get it where it's actually saying not applicable. But, you know, c'est la vie. And then we'll just check the actual time zone. Because, I mean, essentially we're just doing the same thing on every single virtual machine anyway. So we should get the same results. So, yeah, Europe, London for the time zone. So there is one last thing I want to show, which is if we have a look at one of the actual machine files, because what I did as a kind of a cleanup job was to change the actual state from new to present. So if we have a look at this one here for the one that's got a virtual machine ID of 100, see how the state is now set to present. So these are the virtual machine files that I'll be maintaining, but we actually get it to create a dictionary file. And if I have a look at that, that's the file that it creates in our group_vars / PVE nodes folder there. As you can see, what it's done is to basically assemble all those 3 files that we created. So it started with the header up here, which only had a line of computers : and then what we've got is those actual virtual machine files that we maintain. So this is something that Ansible needs to see so that it can do this looping, creating all of these virtual machines. But I've also got a similar file for the images. Just copy and paste. No, I don't want read only. Just paste that. I want to look at that file there. So that's the images file. So that's the equivalent of that one, except it's for a dictionary of actual images that we want to get Ansible to use. So you can see how it's got the header at the top, which is the name of the variable. Then we've got the actual individual files here that we maintain, but it assembles together. So that's good to see. I mean, we've got all our individual virtual machines that we're creating and maintaining through these files, individual image files that we can use for Cloud-Init, but we've also got virtual machines running on different Proxmox VE nodes with different settings. Some use DHCP, some will use IP, some have got different hardware settings, and that's all done just using Ansible and a playbook that's running multiple roles. Now obviously all we have here is some virtual machines, and although they only have an operating system installed, they are ready for Ansible to work on. That means we just need another playbook to install and maintain applications, services and firewall rules, as well as to keep the operating system up to date. At that point we have the whole process automated and only need a backup copy of the Ansible files and any data, if any, we need to keep. They should save a lot of time in the event of a disaster recovery, but it also reduces the cost of keeping local and off-site backups because we aren't backing up operating systems or software for lots of computers. Another benefit of automation is that it maintains the computers to a set standard, which includes the security settings. But let me know what you think in the comments below. Now if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourself that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.